I guess we can start. Welcome, everyone. Happy that you decided to join our webinar today. I'll make just a short introduction about our company, and then I'll hand over to Dr. Igor Osipov from Cite, who will do the presentation. Our main topic will be Cite, but I'll just want to introduce our company. We are AIP, or Albertina e-commerce Prague, and we've been since 1991 in the business of selling electronic information and tools enabling its effective use. And we are working in the Czech Republic and through our 100% owned daughter company also in Slovakia. We work with quite a good number of international publishers with the likes as ProQuest, Oxford, Elsevier, BMJ, and many others. You can see some of the logos here. And we also work with both national license centers in both countries, CzechILib in the Czech Republic and the Center for Scientific and Technical Information in Slovakia. From the very beginning, we've been also offering tools that provide for effective usage of electronic information services. And Cite is among them, I would say, a premium one. So we'll concentrate on Cite, and I'll ask Dr. Igor Osipov to take over the presentation. Thank you.
Thank you very much, Vladimir. Let me share my screen. Welcome to our webinar. Just screen. I think I did. Okay. Can you see my screen, ladies and gentlemen?
Yes.
Okay, perfect. So again, welcome. I'd like to spend maybe 5 minutes on the slides and then go into the platform and show you what Cite can do for you. Just a quick introduction about us. I'm not going to read any of this, so it's really 5 minutes. We've been around since 2018. First 5 years we spent building direct relations with data custodians, data holders, publishers. So we have many indexing agreements with key global publishers to essentially receive publications data from them directly, because a lot of people are asking, where do you get data? Are you similar to this or that? We are an independent data holder that's receiving data from publishers worldwide. So in terms of who's using Cite, surprisingly, about 50%, which is half of everybody who's using Cite, are actually students. That is something that we believe is very unique. And the rest of the user community is researchers, librarians, administrators, so very wide audience. We've done some statistical analysis, how many people are using Cite, and in 2022 we had about 130,000 people, and in 2023 we ended, but essentially in 22nd year we had 130,000, and at the end of 2023 we crossed 600,000 user community, which is quite large. And so in terms of what we actually do, I think the whole idea of Cite was to address the science reproducibility gap, because there are so many articles, books, monographs, repository items appearing every year, and even among the published articles, there are, I think, several million, 8 million people say 8-9 million appearing every year. So very difficult to say what's quality science, what's not quality science, what science is trustworthy, and what is not trustworthy. So we've so far, working with publishers, cataloged more than 1.9 billion references, and through access to full text. And that's both full text in terms of open access full text, as well as behind the paywall full text. articles, we were able to extract more than 1.3 billion citation statements. And that's really at the citation statements are at the core of what Cite does. And this is how we address the science reproducibility gap. So essentially, you can have an article or scientific publication from any field, from life sciences to physics, and from humanities, history, philosophy to social sciences, etc. And so what we do with full text, we identify in-text citations first. And instead of just having that, small line or half of line of actual reference citation, we then extract through the licensing agreements a lot of relevant text, which means several phrases before the citation and several phrases after the citation. What then appears is what we call, a citation statement. So it provides you with a context in which a reference or a citation appears. And then what we do, we classify citation statements into three categories: supporting, mentioning, and contrasting. So in this particular example, we have a supporting citation statement. Why? Because here it says, in accordance with a previous report, then the reference to that report that they're addressing, and then the author continues his scientific claim. So it means that this research team was able to confirm through experimentation or through some empirical evidence the results in this scientific publication. So the scientific publication to which they are referring. So that gives us an idea that, very clear idea that it is supporting. Those constructions can be different. It could be we found similar results, or we've been able to replicate, et cetera, et cetera. And those are giving us very clear idea that this is supporting. It's done now through deep learning, machine learning algorithms in a very good confidence kind of level. Originally, we trained data manually through taking 60,000 articles, and then 2 researchers per article were doing the manual work of classifying, finding and classifying all the citation statements. And so that was the kind of the first training data set, and then we automated it, and now tens of millions of publications are going through this process. Then there is a lot of mentioning citation statements, and those come from methodology sections, from literature review, from just discussions within a scientific publication, and those are non-judgmental. So they're neither supporting nor contrasting. And then there is a sizable corpus of contrasting citation statements, and those can be really interesting in terms of they could say that we failed to reproduce XYZ report, or our results are different from XYZ paper. And so this is something, again, very unique to what Cite can do with scientific data. This is my last slide before we go to the platform. And so it speaks to the scope, scope of data that we cover. And we do cover a lot more than just research articles. We cover sources such as books, monographs, book chapters, preprints. So we cover a wider range of peer-reviewed literature. More than 185 million publications is the rough number that we're covering at the moment. We synchronize data with ORCID in terms of author profiles. We also have direct partnerships with Crossref, OpenAlex, and many other sources of individual publishers, of course, and big archives such as Archive, MedArchive, bioRxiv, et cetera, et cetera. We have lots of affiliation dashboards, so you can look up any university or college or funder, foundation or research institute or company worldwide, and see how their citations live and how their research work is being supported or contrasted or mentioned elsewhere. We also have publisher dashboards and journal dashboards, so you could look it up there as well. At this moment, I think I will just jump into the platform and give you an idea how it looks and what it does for you as a researcher. Just give me a second. I will now share my screen again with you. Okay. So this is my example. Just give me a second again. Yeah, right there. So I'll give you a couple of examples how Cite is used by different publishers, for example, and as a function of that, how users can see the value from Cite. So this is a biology letters journal from the Royal Society. It's just an example, and a relatively highly cited article on alien species, which is about, I think, non-native species of animals, birds living elsewhere, except their kind of regular environment. And so, as a good article from a good journal, from a good publisher, it's been cited many times. And so, if you look up, that cited by list, it will reflect a classic view that just about any index or any publisher is actually providing to you now, which is just a flat list of articles. So why this article cited here, or why this paper is talking about this one, we don't know until we actually click on it, open it, and read it. And again, it's exactly the same for Scopus, Web of Science, PubMed, just name it. This is how classic view of cited by data is provided to you. And so this is where Cite comes handy. Because we have such a comprehensive database of references, we are immediately able to see not only citing publications, but also citation statements and nature of a citation statement in those cases. And so we could, through, this is called Cite Badge, and many publishers already use it. It's already live on millions of articles, not all yet, but many. And so what it shows a report, Cite report for this same article, based on how we can get this all this data from other sources and see how people actually discussed this paper. So you're getting a Cite report. This information will be just about the same. So some metadata, authors, title, abstract, the link to the original. But then again, the unique side of Cite will be in here. And let me probably just log in. Just give me a second. I'll log in. Probably I was showing how to log in a recent discussion, and I appear to be shown logged off. So I'll just log in right now so you can see full picture together with me. Yeah, okay. So it's now done, and I'm returning back to the screen. Yeah, so now we will be able to see everything as we should. So essentially, a Cite report for the same article from our Royal Society has already all the publications that cited my article, but also citation statements. So we can see that there are at least 862 publications that cited this article. And from those, we were able to extract 567 citation statements. And of those, 6 are supporting, 548 are mentioning, none contrasting, and there are a few unclassified. So this means that this piece of research is reproducible. At least 6 independent teams arrived to similar results and supported the data in that paper. And the example of that would be right in here. So there is an article from Nature Communications published in 2020, where they actually referred to my article that I'm looking at, and they were saying that these results are in line with previous findings. So their findings confirmed, because they're referencing my paper here, that this is exactly how things are based on much later scientific data. The next example is biodiversity conservation paper published in 2016. And it says here, our data are in agreement with global patterns that identify human-induced change, et cetera, and then they cite this article right here. And there are more cases here. So you could actually see how a topic, or in this particular case, a certain article, is being discussed by the peers within a community. And you can not only kind of understand what who those people are and what kind of publications, but you're actually seeing the context of those citations right away. You can then see what kind of publications are referring to the article. A lot of them are also articles, but there are also books and preprints and research reports, meta-analysis, comments, data sets, validation studies. So a pretty wide range of formats that is actually referring back to the article. So that's one example. Another example is from archive. It's a different kind of format of data. So it's from physics, I believe. So in archive, it's a preprint. So you could see some basic information, and then you can see who's citing that. And in many cases, for example, in archive specifically, every record would have cite badge. And you could also see if this preprint has been reproduced by other research teams, or is just something that's being claimed without any support. So in this particular case, it's been cited by 134 publications, and we extracted 235 citation statements. And of those, 4 papers supported this preprint. So it's a reliable data from physics, although it is a preprint. Because I'm slowly going to the AI part of this, but already halfway through. So because we have such a lot of publication and reference data, you can really cite directly without even any AI involved in this particular case. So you can search it on just about any topic. And if you look up, what kind of publication types it is covering, you can see that, again, it's not only articles, but also a lot of books, a lot of reviews, a lot of preprints, case reports, comparative studies, letters, comments, editorials, trials, clinical trials, systematic reviews, historical articles, validation studies. So a variety of formats that science now is kind of living. Science doesn't live only in articles. It also lives in other forms. So we are trying to really kind of work with those forms as well. And direct search works very simply. You just can do laser physics like that. Keywords, you could do advanced Boolean queries if you wish. So the laser physics, and it's just an example again, it gets us 250,000 of results. And then, of course, we could see who are the authors, what are the years, what kind of journals are publishing these papers on laser physics in this particular example. What are the affiliations? What are the publication types? Again, if there is a particular one I want to see, that's another one. Editorial notices, this is something also unique to us. We are aggregating editorial notice data from all the publishers, and we know what papers are retracted, what are withdrawn, which have errata, for example. You can search by MASH terms specifically, MASH categories or PubChem, substance names, and it'll get you a lot of relevant data right away. But again, the unique side of cite would be, okay, 250,000 results on laser physics. So what if, this is a lot, so it's very hard to look at. So maybe I'm doing something very different now. I'd like to see only those results that are heavily supported, which means that I just filtered those 250,000 of results on laser physics. And now I just like to see only those that were supported by other papers, at least 40 times. So, and now I'm getting, instead of 250,000, I'm getting 130 results, which is a zoom in to highly reproducible science. And in this particular case, every single paper I'm looking at has been supported at least 40 or more times by other papers. So 145 times here, 55, 40, 49, 51. So, and that gives me a very different way to look at, again, affiliations, journals. Now, Nature is right there on top. Now, the years are different, of course. Instead of starting in sometime in 1900s, it's starting in 1976 and goes in here. Authors, et cetera, et cetera. So that just gives me a really good way of zooming into highly reproducible science. I can be, of course, less aggressive and do, say, 20 or 10 supports per each paper, which will then increase the results range for me. So that's another example. What you can do as well is, if you're good at Boolean queries, you can create a Boolean query and apply it to the entire data set that we have with and or not, describe a very specific or special subtopic of something, etc., and then just get into a real kind of nitty-gritty details of that topic. There are a few other things you could do. You could build custom dashboards. In building your custom dashboards, you can use your reference libraries. You can use Zotero, Mendeley, or any other library that will be able to produce to you a CSV file with the DOIs. So as long as you have DOIs of your favorite papers, you can create a dashboard from that collection of papers that you trust, and then it will show you all the references and all the types of citations that those papers received in an instant kind of view. Maybe one more thing before we get to the artificial intelligence and large language models is a reference check. Reference check is something, again, very unique to Cite, simply because we are collecting data from so many publishers, and then we have our own in-house workflow for all the editorial concerns. So if you have an already published paper in PDF or docx, or a draft of a paper, you can check all the references very quickly, and you just drag in here the file. And for an example, we have a special kind of link for just the paper. And so what the algorithm will do for you, because we have such a comprehensive reference database, it will pull out all the references for you in a list, and will show you the actual kind of context of where that reference appears. But at the same time, it will see if there are any concerns with any of the references that you use. And in this particular example of a paper here, we had 44 references detected, and 2 of them had editorial concerns. And that is a pretty big thing here in this example. For example, here there is a paper in Cell being referenced, which Cell is one of the best journals in the world. But that paper was retracted in 2015, so 6 years after it was published. And so you can see it here. We track it. We're tracking it, and you can then just delete that paper from your list, unless you want to really speak about retractions. And then another one just has a erratum. Erratum is a less kind of dangerous thing. But those papers that are retracted or withdrawn, this is a very good instrument to look at things very quickly and get your analysis done. So now I think I'll be going to the AI, and we are very particular with our view on large language models and generative artificial intelligence. So we were working with it for more than a year. Then we saw a quick rise of OpenAI, ChatGPT, Bing, and all the other large language models. And all of them have 3 very challenging features to it. Although, again, this is extremely talented way of working with data, right? But those 3 shortcomings are pretty universal to all of them. the challenge number one is that those LLMs create very good-looking texts that can be nonsense at the end of kind of when you read it. It looks great, but sometimes for us scientists, it can be nonsense. So the second problem is that often large language models create citations that don't exist. So that is called by some researchers hallucinating citations. And that's another big deal for us because we have a real life citation database. And then the third challenge is that some of the large language models are finite in their scope of training data. So for example, we're now in January 2024, and I'm asking big, large language model to give me an answer on something that happened in 2023. And for example, the training data set for that language model ends at the end of 2022. So inevitably, there will be challenges with the answer because the training data is not updated all the time. So at some point it ends, and then all the rest of the queries and answers will be following a certain data set that is again finite in its nature. So that's why we created Cite, and it's not a large language model of itself. It really works in a very peculiar way to validate large language models and your questions with real life science. So for example, how does the structure of a protein affect its function? So what we do, instead of how other models work, first we decompose the question into a number of searches. And those searches, each can be applied to the entire database of Cite. And so the algorithm first sends those searches to our database. And then each search is consulting with a list of literature and tries to find a really relevant literature first, and then work with that literature in order to start answering the question. And then at the very last step, we allow the system to synthesize the answer based on a special kind of a reference that it's using. So every statement will have to be grounded in real life science. And then at the end, you have an answer, but that answer is in no way nonsense. It always is grounded in science. It does make sense. Whatever it is referring to, you can search and check and double check. So there are no hallucinating citations. All of them you can cite or find or add to your dashboard or view full text from which it was taken. And then because, again, we see these tools as human-guided AI, so we don't let it just live by itself. There is a settings panel where you can exercise a great degree of control over what happens inside of the process. So it's not a black box. You ask a question and then you get an answer, but what happens in between you have no idea of. So here is a very different thing. So you could also and always follow the process and also define that process, whether you want to use references, never use references, whether you want to look at abstracts when you're generating the answer, or citation statements, or both. If you want to do a year range, say, I want to ask a corpus of data that's 100 years back in time, or I want to ask a corpus of data that's just last 3 years, for example, or I want to use a certain citation style. If I'm looking at the answer at the end. If I want to use some journals that I trust, for example, I want to use Science, Nature, and Cell. And my question will be directed to data only in those journals and all the issues of those journals, back in history. Or if I want to only, have like last 10 years and only those 3 journals. Or I want to have 100 journals that I trust, and I can list them in here and then give the range of years to get that kind of information. I can connect it to my Zotero or Mendeley or whatever dashboard you have, and ask your question to the collection of your papers that you trust with the DOIs that you've been able to collect throughout your research career, for example, or something that your professor gave you as a reading list, if you're a student, for example, and then apply that and redo the question and get some real life validated answer so far. So I'll stop here and see if there are any questions.
Thank you very much, Igor. Are there any questions, anyone, regarding the site database or the AI site assistant? Please unmute yourself if you want to speak.
Or if you're shy, please use chat window. That's fine too.
Okay, it doesn't look like. I've got one question. On which of the large language models is the site assistant based?
It can be connected to either of them. Currently, we use ChatGPT, but we also connected it to other large language models when it was down. Yeah, so it's kind of a unselective, but currently we believe that this is the easiest way. But again, because we are very peculiar with what we want from LLMs, right? We're only allowing it to happen at the very end of the process. So I think that's pretty important to highlight.
Yeah. Thank you. Any other questions, anyone? Okay, so in that case, I'll just show you one last screen so that you get contact to us. So here you've got my email and email of my colleague and some. If you have any questions regarding how site is priced, then direct those questions to me. If you have any technical questions, then please use the other address. By the way, there's a free version of site, although of course its functionality is limited. Then there are premium versions of site for individuals or groups, and of course the best is a site license to site which provides access to everyone within an institution. So thank you very much for taking part in our webinar today. Thanks very much to Igor for the presentation, and we'll be looking to receiving your feedback and possibly other questions as well. Thank you very much, and I wish you have a nice afternoon and evening today. Thank you.